Cauchy-Riemann equations trick. I made these tricks after going through finding a way to prove this equation, but then at the end I ended up finding these tricks. And listen, this is a complex analysis question, and before coming here, I am sure you know what it is. I will not go into explaining how to get the equation. I only want to talk about the tricks on how you can memorize the equation yourself. So I'm going to be showing you that we have we have v, who is a function of x and y. I will have u as a function of x and y too. These are dependent functions, v and u, and then x and y are for independent function. And then these two people may give us equation which is used in complex analysis, and which is used to show that a complex function is analytical or is analytic. So how can you remember the formula or the equation for Cauchy-Riemann? Now I have these two tables. Remember, from alphabet we have all these letters are for alphabet: v, xy, and usy. They are all alphabet. So in my alphabet I have dependent function and independent function. We have position. The first one u, and then the corresponding one is x. From the number x, y, z. Okay, u, v, x, y, z from the alphabet. U, v, x, y, z. So the first one is u and x. U and x in the first position. Second position, we have v and y. These are two positions. Let me use this to differentiate between the rows and the column for this. This is the first row, u and del u over del x. Is equal to the second one, del v over del y. This is the first Cauchy-Riemann equation. First row is equal to second row. That is how we do it, considering the dependent and independent variable. U and v, they are the dependent variable. Then when we go from one position, first position now, over second position, is a wrong thing. It should be first position to first position of dependent and independent. Now when you now go from first position of dependent variable to second position of the independent variable across the rows, then is a negative, because it's not supposed to be so. All right, so we have del v over del x, because they're going to cancel each other. They are canceling each other because they're negative. It's not supposed to be negative. One major trick here is this: the first row, that is the first position, del u is del x in the first position, which is equal to del v del v del y. Then when you now cross from first position of the dependent variable to second position of the independent variable, then you are looking for negative, because it should be first over first and second second. But then you are going from first into second, then it's a problem. You are dropping in your position from del u to del y, then that is a problem. Then we also have del v over del s is going to be equal to minus del u over del y. That is the trick I use each time I run out of ideas trying to figure out some things about this. I always use. Okay, let's go through a quick revision. When you are going from dependent function over independent function, for the first one, that's correct. First dependent over first independent, and that is equal to the second. But anytime you drop from first position to meet the second position, you have negative.